These questions are by Christos Nicolaides, teacher. So I will leave the link on my description. Please visit his website and check the questions there. So number 1, quadratic functions has a maximum value of 5 when x equals 3. So actually this gives us the information of vertex. So vertex is 3, 5. So here P and Q, we can convert this standard form of quadratic function into the vertex form, x minus 3 squared plus 5. So when we have the vertex P, Q, and leading coefficient of A, then we can have A x minus P squared plus Q. So this is a little bit confusing, P and Q. P is minus, Q in plus. So here minus 3 plus 5. So when I expand it, x squared minus 6x plus 9 plus 5. So negative x squared plus 6x, negative 4. So P is negative 4, Q is 6. So this is translated 3 unit in the positive direction parallel to the x-axis. So this one, 3 unit to the right. So I start from here. Actually, transformation is a little bit easy to make it from this vertex form. So here, no, actually, since we have this, the new, whatever you want to start from, where you can start from anywhere. So now anyway, we are making 3 unit to the right, which is x minus 3. So instead of x, we can put x minus 3. So now x minus 3 minus 3. So now we have x minus 6 squared plus 5. Or here, negative x minus 3 squared plus 6x minus 3, negative 4. Minus 4. So wherever you are, all x need to be changed into x minus 3. So I will expand this. Negative x squared minus 12x plus 36 plus 5. So this becomes negative x squared plus 12x minus 31. So this is the new graph. Y equals negative x squared plus 12x minus 31. This is f of x and g of x. So now single transformation from g of x to f of x. So all the x-intercept are same, but y-intercept from 2 to 3. So I guess that this will be the stretch, like vertical stretch. So this is vertical stretch. By a scale factor of 3 over 2. So that's why 0, 2 goes to times 3 over 2, 2y, 0, 3. So this is A. So inequality f of x is larger than g of x. So that is during here, f of x is like upper than g of x. So this one, we need to see the graph itself, but when we answer the interval, we need to give the interval of f of, the x. So when x is between negative 1 and 4, f of x is upper side of then g of x. So f over 4, so f over 4. So f over 4 equals 0. So f over 0 is 3. So this one, f g of x equals 3. When f is 3, which is here, g of x but not only there, this and here. So g of x can be 0 or g of x can be 3 because f of 0 is 3 and f of 3 is 3. So g of x can be 0 when x is -1 or x equals 4. And g of x can be 3 when x is -1 or x equals 2. So there are 4 possible values of x. X can be 1, 2, -1, and 4. And number 3. So it has x-intercept, which is 2. It is x-intercept 2, y-intercept -2, horizontal asymptote y equals 2, vertical asymptote x equals -2. So let's start from x-intercept. So a should be -2 to make the x-intercept as 2. So y-intercept is 2, so maybe c is 0.5x. C is 0.5 to make it 2. And for the y-intercept -2, this should be 1. So in this case, x-intercept is -2. So this is the one. So a is -2, b is 1, c is 1/2 or 0.5. So sketch of B, C, O, now we have different. So A equals -2, B equals 1, C equals 0.5. So let's go here. So now we need to sketch the graph. 1 plus 0.5x and -2 plus x. Actually, this is the reciprocal of this one, like a flip, and modulus. So let's draw the modulus graph here and reciprocal graph and apply the modulus. So here, when it is x-intercept, it becomes the asymptote. So x equals 2. When it was vertical asymptote, it becomes to 0. So the horizontal asymptote was 2. So now horizontal asymptote is 1/2. So y equals 1/2. And what we have, so -2 was -1/2. So like this. So now we can draw the graph. Approaching to the asymptote. So like this. So this is the graph of the reciprocal. But we need to draw the graph of the modulus. So eventually, the positive side stays there. So this stays there. And the negative side need to come up like this. So this one is the graph of this modulus side. So after we apply this modulus, so this is the one. So 1/2. And let's go for the next one. X cubed minus x plus 4 has this real root -1.796. This one, let's say, compared to this one and this one, what is changed, which is x. It was x, but now we have x minus 1. So we can tell if we have the function of x cubed minus x plus 4, now we have like 1 unit to the right. So if we have the graph, the x-intercept negative 1.76 or something like this, then we may have, because now we move 1 unit to the right, so the x should be negative 0.796. And this one, what is changed? 2x cubed minus 2x plus 4 equals 0. So it was negative 1.796, in the original function. So the first one has this 1 unit to the right. So now we have this root. Now we have 2x. So when it becomes a 2x, it is the horizontal stretch, but it's not stretch, compression by a factor of 1 over 2. So this becomes like negative 1.796 over 2, 0. So negative 0.898, 0. So this will be the x-intercepts. Therefore, the real root becomes negative 0.898. And this is the, actually this is the same graph we saw from the part 1, but we can try once more. So x-intercept comes from numerator. So when numerator is 0, this is the 0 of this rational expression too. And when denominator is 0, it becomes to the x-intercept. Vertical asymptote. So 5 is vertical asymptote. And we can find y-intercept f of 0 over 0 over 0. F of 0 is negative 3 and negative 1, which is 3. Makes sense because this part, they have the same sign. Both of them are minus, so negative. So which means when we divide negative over negative, then it becomes positive. So this becomes like this. And this 1 positive, 1 negative becomes negative. And this one, both of them positive, positive. So this is positive. But the denominator is 0, which is positive, infinite. And this one is not very clear. But they have like opposite signs, so let's make it like this. So this can be the sketch of f over g. And this is the one combination of two reflection, negative f, negative x. So this is vertical reflection, like reflected over the x-axis. And this one over the y-axis. So this is a half turn of the graph, f of x about the origin 0, 0. So which means, if you get confused what this means, then you can apply this one. So when we apply the y reflection and x reflection again, like this. So this is the half turn. So 180, when we rotate it 180 degree, at the center, with the center about the origin 0, 0, this becomes like this. So on the same axis, half turn of the graph of about the point 2, 0. Okay, so from here we can make half turn. This can be like this. So considering half turn into appropriate translation, half turn of f of x about 2, 0. So this can be given by negative f 4 minus x. So negative x minus 4. So which means when we rotate twice of, not rotate, reflection twice, negative f, negative x, and we go to the right side 4 units, then we see this the second graph. So it makes sense. And and find the expression for the half turn of f of x about the point a comma 0. So maybe when we make a comma 0, let's say half turn, for example, if it is 1, let's say, then when we reflect it here and here, so this becomes, this one comes to the right 2 units. So now we found the patterns. So g of x, let's say not g of x because we already used that. So h of x is f like twice the reflection, but it need to come twice, double of the center to the right. So minus 2a, like this. Maybe negative f 2a minus x may be the half turn about the point a comma 0. So horizontal asymptote is y equals 3 over 2. So here x is 3 over 2. Vertical asymptote is x equals negative 2, y equals negative 2. Because f of x and f inverse of x, they interchange x and y. So x-intercept is 1 over 3, 0, y-intercept 0, 1 over 3. 0, negative 1 over 4, negative 1 over 4, 0. And reciprocal. Reciprocal is like 2x plus 4, 3x minus 1. So vertical asymptote is x equals 1 over 3. Yeah, x-intercept and vertical asymptote exchange each other. But you don't need to memorize it about this relation. Just think at the moment. And we can memorize about the relation of 0 and infinite. Both of them are 1 over 0 is infinite, 1 over infinite is 0, something like that. So they are very reciprocal relations. And y-intercept here, 0, negative 4. And horizontal asymptote, y equals 2 over 3. So now f of x, so 2 over 3. Three over 2, sorry. And x vertical asymptote, y equals negative 2, x equals negative 2. And 1 over 3, 0, negative 1 over 4. So when we draw the graph, f of x becomes like this. And corresponding position, horizontal asymptote of f of x. So originally, f of x horizontal asymptote is y equals 3 over 2. So this will be affected only by the vertical transformation. So the first one, vertical stretch, so it get affected. So y becomes 3. This is vertical translation, up 2 units. So this becomes y equals 7 over 3, which is, 2, which is 2 plus 3 over 2. And the third one, this is translation of horizontal translation. So we don't need to change it, y equals 3 over 2. And this one is vertical reflection, over the x-axis. So y equals negative 3 over 2. So it was 3,0.8 was on f of x. So now we move like this. So y2 f of 3 x minus 2 and 5. So first, let's say y equals 2 f of x. 2 y equals 2 f of 3x. 3 y equals 2 f of 3 x minus 2 plus 5. Let's go together. So the first one, vertical stretch by a factor of 2. So y, only y can be doubled. So 3,1.6. And number 2, only x becomes 1 over 3. So 1,1.6. Because this is the compression by 1 over 3. And now go to the right 2 unit, 5 unit up. So to the right 3, 6.6. This is the last answer. And number 8, vertex is x plus 1 squared negative 4, negative 1, negative 4. X-intercept, x plus 3 and x minus 1. So negative 3, 0, 1, 0. So we draw this graph on the same here. So now we have y-intercept negative 3, x-intercept negative 3 and 1, and negative 1, negative 4. So this is the f of x. And when we draw the reciprocal of f of x, zeros becomes the asymptote. So x equals negative 3 and x equals 3. Those are vertical asymptote. And negative 3 becomes negative 1 over 3. And negative 1, negative 1 over 4. So now we draw the graph. And the end behavior, those are goes to the infinite on both sides. On both sides. So now we go to 0 because it's like reciprocal. So we have y equals 0, horizontal asymptote. So infinite to 0 and as the reciprocal, so 0 to positive infinite. And 0 to negative 4 to 0. Then negative infinite, negative 1 over 4, and negative infinite again. So the last part is 0, positive 0 to positive infinite. So positive infinite to 0. Like this. So this is the reciprocal graph. So here domain range, f of x, all real number. Range y is larger than or equal to negative 4. The domain here, x cannot be negative 3, x cannot be 1. So range y is larger than 0 and y is smaller than or equal to negative 1 over 4. 0 is asymptote, so it cannot be 0 itself. And this one, f of x, when we put in the square root, only this part can be inside. So here, domain x becomes negative 3, like a smaller or equal to, and x is larger than or equal to 1. And when we put them in the square root, still 0 is 0, infinite is infinite. But we move them 1 unit up. So y becomes larger than or equal to 1. And when we make them into the infinite, modulus sign, all of them, So here and here, they stays there, and the negative part goes up like this. So domain all real number, but range is like y is larger than or equal to 0. And when only x has this modulus sign, this part remains, and it is copied on the left side, the exactly same, and we ignore all other parts. So now all real number can be x, and y is larger than or equal to -3. So x squared to be f of x. So this one, when we see the transformation of this quadratic, x squared, we always check this vertex form because this is clear how it moves. So this one we can say translation by -1 and -4, like to the left 1 unit, 4 unit down, like this, or 1 unit to the left, 4 unit down. Any of them you can answer. So number 9, sketch the graph of each of the function. Is this the last one? Yep. Okay, so this one, x plus 1, x minus 1, and x minus 3 squares. So f of x, -1, 1, and 3. And leading coefficient is positive. And we start from the right side, like a right upper side. But we have 3 twice, so we just touch. It doesn't cross the x-axis. So like this. And 1 and -1, 1 cross, -1 cross, like this. So this is f of x. And the y-intercept is -9. So f of x, 1 over f of x, the 0 becomes asymptote, -1 over 9. And there was no asymptote before, so we don't have any zeros. So let's start, and this has the y equals 0, horizontal asymptote, because original graph goes to infinite. So when it goes to infinite or negative infinite, we have this horizontal asymptote, y equals 0. So this part, do it like this. And this part goes to negative infinite because it was -0. So this is a positive infinite because it was +0. So +0, positive infinite, and +0, like this. So this is the graph of f of x. And number C, we have the rational expression. So let's analyze it. X-intercept L1, 0, -1, 0. Y-intercept -1 over 9. And horizontal asymptote, because both of them like quadratic, both sides. So y equals 1 over 1, which is 1. Like the highest degree. And vertical asymptote, x equals 3, which the denominator becomes 0. So x is 3, y equals 1, and 1 and -1, and 0, negative 1 over 9. And we need to analyze one more thing. So upper part and the lower part, both the 0, negative 1, 1, 3. So we analyzed x plus 1, x minus 1, and x minus 3 squared. So when we input like number 5, let's say, it is positive. Now we know number 3 has twice. Number 1, this equation has this. We call this critical numbers. So we have critical number 3 twice, and negative 1 and 1 once. So 1 and negative 1, we have sign changes. But 3, we don't have any sign changes. So we still have a positive because it doesn't have sign change. It doesn't change any signs. Negative, positive. So here the graph, here is negative 1, this is positive 1. So on the right side, the 3, positive. So this should be like this. And between 1 and 3, it is positive. So maybe like this. Between 1 and negative 1, negative. So like this. And positive. But we also need to go to the horizontal asymptotes. So this graph looks like this. So now we will draw the 1 over g of x. So again, here x equals negative 1, x equals 1. And this can be 0. Asymptote becomes 0, 0 becomes asymptote. And negative 1 over 9 becomes negative 9. Y equals 1, still y equals 1. So this one on the left side was 1, 2, 0. And now we have asymptote. Reciprocal. So it goes from 0 to infinite. And this side, negative, like a negative 0 to negative 1 over 9 to negative 0. So here, negative infinite to negative 9 and negative infinite, like this. And yeah, it doesn't show very well. Let's see if I have the negative 9 a little bit higher, for example. Let's say if this is negative 9, then graph is like this. And on the other side, between 1 to 3, it was 0 to infinite. So negative infinite to positive 0, like this. And like from 3, it was from positive infinite to 1. So now it becomes 0 to 1, like this. This is the reciprocal graph. Now we have asymptotes. X minus 1, x minus 4, x plus 1, x plus 4. So vertical asymptote, x equals negative 1 and x equals negative 4, like as an equation. Horizontal asymptote is y equals 1 because x squared and x squared. Intercept, x-intercept 1, 0, 4, 0, y-intercept 0, 1. So given local maximum looks like this, local minimum looks like this. So now we will sketch the graph. So let's do that. Horizontal asymptote, negative 1 and negative 4. Vertical asymptote. Horizontal asymptote is y equals 1, 1, 0, 4, 0, 0, 1. So now we need to draw the graph, but we need to analyze this sign changes. -4, -1, 1, 4. If we put like a 5, then it's positive. All of them has only 1. So all changes the signs. So plus, minus, plus, minus, plus. So on the left side of -4, plus. And we know already all those asymptotes. And between -4 and -1 is minus. And between -1 to 1, positive. But 1 should be 0. 0 to 4, negative. And positive. Oh. But we need to go to this asymptote. So this is the graph of f of x. So maybe this is the one, no, this is the one, -2, -9, which is the maximum. And this is 2, -1/9. Yeah. It's a little bit, yeah, I didn't think about it. So the graph, the position is a little bit strange, but it is. So find the range of f of x. Let me move this like this downwards, like this. So let's find the range. Y is larger than or equal to, then -1/9, or y is smaller than or equal to -9. And number E, f of x is smaller than 0 when x is between -4 and -1, which is smaller than 0 is this part, and x is between 1 and 4. So solve the equation f of x is larger than or equal to 1, which is this part. So x is smaller, smaller than -4. No, actually smaller, because the -4 is not inclusive because it's asymptote. And x is between -1 to 0. This is the answer.